everyone. Welcome. My name is Ioana. I'm really glad you could join us today. And I'm excited to introduce our speakers from Oracle. We have here today Meliana Malay, Rahul Tasker, Denise Myrick, and Ramu Murakami Gutierrez. So today's workshop, Improving Your AI and ML Predictions Using Location Data, will show you how location intelligence and spatial AI in Oracle Autonomous Database can make predictions smarter and more accurate. We will be using some real-world examples, and this is a hands-on session, so get ready to follow along. As always, please drop any questions you may have into the chat. We'll make sure they get answered. And that being said, let's dive in. So Ramu, over to you. I'm gonna start presenting now.
Awesome. Let me go ahead and share my screen really quick. 1 second. Okay. Please let me know when you see my slides. Are you guys able to see it right now?
Yes.
Okay, awesome, perfect. Well, hello everyone. I'm very excited to be here with all of you guys today. As we heard in our presentation, we're going to be talking about how to improve AI and machine learning predictions using location data. So everyone has location data, as you guys can see. Some of you shared where you guys are coming from. So very excited topic. I think everyone can resonate with location in general. And as I said before, we all have location data, right? We have our team of product managers for spatial and graph. In this call, we have Melly, Denise, Rahul, and I. So if you have any questions, please use the chat and we'll be able to answer your questions. So I'm going to pass it on to Denise so she can go over how to get started, so how to sign up for your Live Labs account and basically provision your environment. So Denise, if you want to go ahead and take it over from here.
Okay, thanks, Ramu. I appreciate it. Let me go ahead and share my screen. Sorry, I'm kind of new to Google Meet. It might take me a second. Okay. There we go. Can someone confirm that you can see my screen?
We can see your screen now.
Okay, great. So let me go into the slide deck. So the first thing we're going to do is navigate to livelabs.oracle.com. I already have that up, so I'm going to bring it over here. Again, that's livelabs.oracle.com. And when you get into this page, you're going to click this button here, event code. And you're going to put our event code in. And this is the code that is in chat. Maybe somebody can drop it again just to make it easier for everybody. And I'm going to submit my event code. And it's going to ask me to log in. So if you don't have an Oracle account, what you're going to do is click this button here, create account. And you're going to fill in all of this information. And I'm going to give everybody a couple minutes just to do that. And if you have any questions, go ahead and put them in the chat.
I think Hector has his hand raised. I'm not sure if you're able to unmute Hector, so please.
No, he already sent the questions in the chat. He is asking the last step to enter the code. It's in the right top of the corner of your screen to enter the event code.
Yep. So if you go here, I can bring it up. So in the upper right-hand corner of the screen, it will be up there. It says event code. Let me back out of here. So it's this button here, the event code button. and you drop the code in there. Okay, so if you've clicked in your account creation, you put in all of your information and click create account at the bottom, you'll get a pop-up that says check your email, and it will tell you what email address you put in. So you go to your email address, of course, and you'll get a button, or you'll get an email in your email that says to verify your email address. You get 24 hours to do that. So if you're not going to run through the live today, you can do that in your leisure, and then your account will be created. Okay, so once you have an account, I'm going to go ahead and submit my account event code again, and I'm going to log into my account because I already have one. Okay, so now we're into our hands-on lab splash screen, and what we're going to do here is click this green button up the top that says Start, and we're going to click Run on Live Lab Sandbox. We'll consent to receive emails from Live Labs and click Submit Reservation. Now, this is going to provision a Live Lab environment for us. It's going to take a little while. So while that goes on, Ramu is going to tell us a little bit more about Oracle. Let me give it back over to you, Ramu.
Awesome. So let me go back to my presentation. Okay, so can we confirm that we're able to see my presentation?
Yep.
Perfect. Awesome. Okay, so before we get started, I would love to know how many people have location data. They've heard about spatial data, what they can do, have they ever used it? And I can see, okay, so if you give me thumbs up, I would think that you've used location data in your day-to-day basis. Oh, okay, thumbs down is no, we have not used location data. Okay, awesome. Well, so everything happens somewhere, right? So I feel like everyone can take advantage of location data in general, right? Us as people, we have, I don't know, where we were born, where we live, where we studied, where we work, physical location that we can use, right? And this is very helpful because it helps us also create maybe connections with other data that might not have connections, right? So it helps us make a relationship between different entities through location. And it also helps us with adding context to our business workflows. For example, it's important to understand that maybe one place might be more prone to earthquakes or hurricanes for us to be able to understand and prepare for disaster recovery, right? So that's how location data gives us value and is important. So let's talk a little bit about spatial data and what type of questions we can answer with spatial data, right? So the basic way for us to store location data is normally point, lines, and polygons. Points are basically address location, GPS location, earthquake location, and we can answer questions like which address location are within a flood zone, right? Then we have lines that are roads, utility lines, storm paths. So basically it's data that we can represent in a line, right? And it can answer questions like which utility lines are within a mile of an earthquake location. And then we have polygons that can represent countries, flood zones, sail regions, etc. And we can answer questions like how far from a storm damage is the nearest emergency response center. So these are very, very basic ways for us to store our location data. And this is something that we can already store in our database natively. Then we also have a little more advanced ways, advanced spatial data, right? Like 3D raster networks, and 3D data are normally point clouds, lidar, surface solids. Then we have raster data that is satellite imagery, drone imagery, grid data, and then we have network that are roads, rails, utilities. And as you guys can see on the right side, we also have different types of questions we can answer with this type of data, right? So again, this type of data you can also store in the Oracle database natively, right? This is basically a capability we've had for a very long time. It's something pretty mature in the database. Then here we have a couple of examples of what operations we can do with this data, like geofencing, that is normally used for security, logistics, and mobile marketing. Then we have linear reference that basically is for roads, rails, utilities, and spatial temporal, that is a combination of location data with time, right? So for example, a question that you can answer with this type of operation is where two people located within 20 feet of each other for over 5 minutes. It's a question that can help us, for example, in the healthcare industry, and for example, if we're dealing with contagious diseases, etc. So it's a pretty cool thing for you to be able to analyze, right? Using spatial and time. But anyway, so with all of this spatial data, we are able to use SQL APIs to answer very critical questions, right? We have hundreds of spatial operations that you can perform in the Oracle database, and we can answer questions like that are associated to search, measure, aggregation, and comparison. And as you can see on the left side, we have our geometry column, that is SDO geometry. That's the way we are able to store our location data in the Oracle database. And then on the right, we actually have an example of how we perform those basically spatial operations, right? So SDO within, probably we're just grabbing a point that could be within a specific area. In this case, we're prediction, it's a prediction flood area, right? To see whether that parcel is going to be affected if it's inside that specific flood area, right? And the best part, and something that we're going to be covering today, is the fact that you are able to do the most common spatial SQL operations with Python now, which is a language, a very popular language that a lot of developers use and data scientists use. So it's a pretty exciting feature, right? But again, this is basically done in SQL, right? These operations in the Oracle database, and you can perform these operations anywhere. For example, we do have a extension, a SQL developer extension plugin that you can use with VS Code. So I know a lot of developers love VS Code, and I think it's pretty nice that you're able to perform these operations and take advantage of your spatial data. But anyways, let's talk about how we add AI to spatial. So in this live lab or hands-on workshop, we're going to be mentioning a little bit Oracle Machine Learning. That is basically the platform that we use to be able to perform Python APIs. So basically data operation, data preparation, modeling, etc., using Python. And then we're also going to be talking about the Autonomous Database Serverless, which is the database that we use in the cloud, which is fully managed, autonomous, elastic, etc. And the best part is, like, if you're a developer or a data scientist, you don't really have to worry about the administration part, since it's done automatically, right, autonomously. So as we discussed before, we have our basic ways to store our data, right? That are points, lines, and polygons, our spatial data, right? And we can answer questions like the ones we covered before. The difference is when you add machine learning to it, you're actually able to predict and also focus on detect patterns, right? So with our points, lines, and polygons, we're able to predict the impact of a highway project on traffic safety, or maybe predict solar energy adoption for a planned housing subdivision. So we're focusing more on the prediction and the pattern detection using spatial data. And in here, we have a list of common scenarios of how spatial machine algorithms can help us understand, predict, and detect these patterns, right? I'm going to cover just the first example that is basically the spatial effect of predictive influence of nearby values. And a scenario could be with properties, right? This means that, for example, if I'm trying to sell a property that has 2 bedrooms, 2 bathrooms, and a pool, and I go into the internet and I try to find a property that is very similar to my property when it comes to the number of rooms and the number of bathrooms, the fact that it has a swimming pool, and maybe even the square footage. And I just try to grab that price and basically set it in my property. It's not going to be really a very accurate price because we need to have the spatial dependency into place or think about it, right? Because it's not the same living in the countryside than living in an urban area, in a city, etc. So the spatial location data can help me be more precise and more accurate when it comes to setting a price for my property. And that's why spatial data gives us so much value when it comes to accuracy. So here there's a couple of features, spatial AI features that we have. So we have the Python APIs for spatial SQL operations. So we spoke a little bit about the fact that we have hundreds of SQL operations in the database. Well, you can actually perform those using Python, right? Which is amazing. We can also use our spatial data to pre and post processing, meaning that we can enrich our data sets a little more. And we can also use our spatial data to fill in the gaps if we have any gaps and spatial weights, etc. We also have a listing here of all of the ML algorithms that we have available, and we have our spatial ML pipeline for those that are very into data science oriented pipelines. You guys have that available. Here we have a list of all of the algorithms available, and this is coming from the documentation. So if you are curious to see how they work, etc., I definitely recommend you to take a look at that documentation and get a little more information. But we have a lot of different algorithms available. So let's go ahead and talk a little bit about the hands-on workshop before passing it on to Denise. Will be starting the workshop part. I want to go ahead and cover a little bit the scenario, right? So in this case, we will use spatial machine learning algorithms for predicting EV adoptions. And we are going to be covering spatial and non-spatial spatial algorithms just for you guys to see the value of location and to see how it helps us with prediction and detection of patterns, right? In here, we also have the 3 algorithms that we will be using. And then in here, we have the data sets. So we're going to use zip codes from the US Census, and then we're also going to use EV car registration zip codes. We're actually combining these 2 data sets since we want to compare the zip codes that already have electric vehicle cars and the ones that don't have electric vehicle cars. And then we have the demographic by zip code. And as you guys can see in there, our geometry column is a polygon, and we also have the map representation of that data set, right? And then on the other side, we have the EV charging station location. And as you guys can see, we have them as points. That's like our location data. They're in a point format. So let's go ahead and get started with the workshop. Hopefully your instance is already available for you to get started. So I'm going to pass it on to Denise to get started with the hands-on lab.
Thanks, Ramu.
Of course.
Okay, Ramu, do you just mind confirming that you can see my screen before?
Yep, I can see your screen.
All right, so hopefully everybody was able to create their account without any issue. I'm now logged into my account, and I've come over here to my reservations. And to do that, I clicked on my name, and I click this button, My Reservations. And what I'm going to do now is launch the workshop. And I have a lot of workshops here because, well, I do this for a living, but you probably only have this one. And you're going to click Launch Workshop on this button here. And it's going to bring you into the hands-on lab that we're working with today. Just a quick note, in the upper right-hand corner is this time remaining lock down. And so depending on how it was provisioned, you might have a lot less time here than I do. You might want to go ahead and click extend your workshop a few times if you're running out of time at any time during this live lab. But what we're going to do now is click this View Login Info. And you can see here that there's all this kinds of reservation information. There's a lot of information in here, but for this live lab, we're only going to focus on the information down here. But before I get too far ahead of myself, there's some more information here that we want to look at. So here you can see an introduction to the workshop. You can see what we're going to do today. There's a little information system here, and we're going to click on this Get Started button. And it's going to walk us through how to log into the sandbox. And it's going to talk a little bit about the things that we just went over and how to find the reservation. We already went over this, so we don't have to go too far in depth, but I just wanted to highlight that you have this information here if you go through any other live labs. So we're going to go straight into lab 1. And what we're going to do is log into OML UI. And so we're going to click that button here. And we're going to copy our database user password. So I have that when I do my login. And I'm going to take a note of what my database user is. My database user is OML user. And so I'm going to click this button, OML UI. And that's going to launch another screen. And if you have any issues while going through this, go
Denise,
ahead into chat. Yep.
one question. Can we get a thumbs up if your instance is working and a thumbs down if it's not, just to get a quick idea?
Thanks, Ramu.
Okay.
Okay, so we do have some thumbs down, but mostly thumbs up. So the people with the thumbs down, if you're having any issues, why don't you go ahead and put those into chat?
Yeah.
And we can do a breakout session if necessary, but if it's just a timing issue, I'm going to go pretty slowly. You should be able to catch up.
Yeah, Denise. I just saw somebody saying maybe we should slow down a little bit, but I think other than that, if not, we can definitely do a breakout session.
Yeah, absolutely. I can definitely go a little bit slower. Thanks for the feedback. Okay. All right. So my username, as we mentioned before, is OML user, and I can come back in here and look at that again if I forgot. So I'm going to click OML user, or type, I guess, and then I'm going to put in my password. And I got my password by copying the value of my database user password here. So there's a few different passwords on the screen. I have an admin password. I have a password to my tenancy. I want this one here. Okay. And I'm going to put that in and click the sign in button. Okay, great. So now I'm in the OML instance. And what I'm going to do is I'm going to split my screen. So I'm going to put this on my right side, and I'm going to put the workshop on my left side. And hopefully that's easy for you guys to see. Oops.
Sorry, Denise. We're only seeing your instructions. We're not seeing. It doesn't look like you're sharing the whole screen.
Oh, okay. Let me try to fix that. Thanks for letting me know.
Of course.
Okay, I should have done this instead. Is that better?
Yep, perfect. Thank
Great.
you.
Thanks so much. Okay. Like I said, I don't use Google Meet a lot, so it took me a second. All right, so we're now in task 2 of our workshop. So we're in lab 1, task 2. I just logged into the OML notebook environment. So just like it shows here, it looks an awful lot like what we're looking at. Do people want to give a thumbs up if you're at the screen where we are? Okay, I'm seeing lots of thumbs up, so I'm going to continue on. And again, if you want to go into chat, if you have any problems, let us know. And I'm going to click, yep.
Denise, maybe we can, I recommend after task 2, maybe we can pause and kind of have people.
Yes, so the task that I'm going into, everyone, is just a playground environment. So it's not something that will affect the rest of the live lab. So if you're anxious about what I'm going to do next, don't be, it's not going to affect anything. So this is a good thing to do while people are catching up. Okay, so I'm going to click on notebooks. And I'm going to create a notebook. And I'm going to call it testing. And as you can see on the left-hand side, I'm just following along on the instructions that it's telling me to do. And it should be very close to exactly the same on your screen. So we're going to click OK. And it's created us a notebook. So if you look here, it says to hover above or below the empty paragraph to display buttons for creating a new paragraph. So if I look here, I have different types of paragraphs that we can create. And if I hover over any of these icons, it's going to tell us what kind of paragraph this is. So I can create a Conda paragraph, a Python paragraph, an R paragraph, a Markdown paragraph, a script paragraph, or a SQL paragraph. If I click this one, it's just going to create a paragraph with no type attached to it. I want to create a Markdown paragraph. So again, I'm going to hover over the icon to confirm that I have the right paragraph, and I'm going to click on that button. And what I'm going to do is type in what it tells me to type in here. And it's a little difficult to see, but if I click on the image, it tells me, it blows it up a little bit. So let me click on it, and I'm going to type in 4 hash marks or pounds, depending on your generation. Hello, world. And then an exclamation point. Now, a little tip. When I created the Markdown paragraph, I had to do a backspace to bring me back all the way. If I created the paragraph as is, and click run, I'm going to get an error, and we'll see that in just a moment. Just give it a second.
It's provisioning a compute instance. So the
Yep.
first time you run a paragraph, that's why it's taking some time.
Yes,
I know folks have been having login problems. We are organizing a breakout room so we can help folks. I said we will pause after this task to make sure everyone has been caught up. So some people had trouble logging in to the OML UI. I think, oh great, some people are right with you, Denise.
Okay, good. If you're having trouble logging into the OML UI while this provisions, I'll go ahead and show you again. So I'm going to click on this view login info, and I get my reservation information. And I'm going to come down to the Terraform values section. And we're going to focus on these 3 parts: the database user password, and OML UI. So I'm going to save my database user password because it's more complicated. and I'll launch my OML UI, and then I'll type in my database user, which is OML user, and my database password. Those are the ones that you want to focus on. And while we talked about that, my markdown finally worked. I didn't get the error, which is interesting, but if you do have a problem with running any of these paragraphs, that is a known issue with the notebook. You might just have an additional space in there. Okay. Oh, I'm sorry. I'm in the markdown, not the Python. That's the issue. Okay, so then I'm going to create a Python paragraph. I got a little ahead of myself. And I'm going to click here and create a Python paragraph. And I'm going to type in what it says under Python. So it says import OML, and then OML is connected. And I'm going to hit this run button. Okay, and see, this is the error I was talking about. It does have an extra space here. So we're going to go ahead and delete those spaces and try again. And then we get a true. So if you see an issue like that where it says you have an unexpected indent, just make sure that you don't have any spaces before your lines. Okay, and then we're going to hover again and create a SQL paragraph, which is this one over here. And we'll create this SQL script, and it's select count asterisk from user objects. And we'll hit run. And that's just going to tell us how many objects are in our database schema and make sure that we're connecting properly.
Sorry, while that's loading, if anyone needs help, can you please just say me in the chat so I can add you to the breakout room? Thank you, everyone.
Not sure why it's so slow today. Okay, finally. All right, so it's telling us that we have 4 objects in our user objects, so that's great. Okay, so a couple other things from a UI perspective. I can erase all of the results up here, and this will erase all the results from the notebook. And I can run all of my paragraphs from this button. So what that will do is go through all the paragraphs in order and run them all. And I can refresh it here. I can restart the session. But this was just a test notebook. So I can close out of here. And to do that, what I'm going to do is open it up a little bit so I can see better. And I can come back to notebooks. they can click on testing and delete it. And that's okay because we don't need this notebook for the rest of the live lab. You can keep it if you want. Okay, so we're now at task 3. So I'm going to give us a moment for people to catch up. Just people want to give a thumbs up if you're ready to move on, or a thumbs down if you want me to wait a few more minutes.
Just a heads up, I'm moving everyone that said me to the breakout room. It might take a little bit, but you should receive a notification saying join. So give me maybe 2 more seconds.
If you click the button, the dot that small like a few like a square dots at the right bottom of your screen, you should be able to see the breakout rooms, and you can click one of the rooms to join if you need help to set up an account or anything else.
Looks like Hector has his hand raised. Not sure if we can allow you to talk, Hector. Do you want to put in chat?
He said he can join.
Okay,
1 second, let me see.
that's strange.
Hector, are you able to join the breakout room too? I see a few folks are over there.
Okay, should I continue on for the rest of the people, or should I wait a few more moments?
Maybe wait a couple more minutes.
Okay, sure, absolutely.
Thank you.
Simon, are you saying you need an invite to the breakout room or to the live lab?
If the breakout room doesn't work, do you want to try the room and you have the room link? Do we want to go to the using the room to for the instead of the breakout room? Seems like some folks have the problem. Okay, Hector, I see you joined. Justin, you joined. Are you guys okay in the breakout room, or you want to try differently?
Sorry guys. So if you're not able to join the breakout room, just because I see there's a couple of people that are having issues, I'm also gonna open my Zoom. And sorry about that, guys. I don't want to confuse you, but I do have my Zoom link in the chat in case you want to join. I'm also gonna be opening my Zoom. So just don't close the Google session, but go ahead and join my Zoom if you want to.
Okay.
If you can just lower down the Google session. Zoom is the best. We're very new to Google.
Okay.
You guys, so I see a couple of people in here, so I'm just gonna mute myself and continue using.
Okay. Thanks, Ramu, for soldiering on with helping people out. I think at this point I'm gonna move on with the live lab because I'm a little worried about time, and I want to make sure that we have enough time for us to get through the rest of the live lab. But again, if you have any issues, go see Ramu in the Zoom link, and hopefully she'll be able to work it out for you. Okay, so what we're going to do now is go through Lab 1, Task 3, which is importing pre-built notebooks. So I know that we just had you type in some parts into the paragraph, but from now on, no more typing. So we're going to click on this here button to download the file of OML notebooks. And it's going to drop some notebooks into a zip file for you. And then we're going to return to OML notebooks and click on the import button. So that's this button here. And I've already downloaded these notebooks, but you might need to, oops, I don't know what happened over here. You might need to unzip your files to get to them. Can you still see my screen? Something happened weird with Google Meet. Okay. I don't know why I can't see it anymore, but oops. Okay. And we're going to import all of our notebooks. So I'm going to highlight them all and click import. And now we have all of our notebooks imported, 4 out of 4 notebooks. And I can expand the names here so I can see them a little bit better. And so that actually concludes Lab 2, or excuse me, Lab 1. And what I see here is just a little bit more information about what's going on with these notebooks. So you can read about the different libraries that we're going to be using, and these links go to more information about all of them. But I'll let you guys peruse that on your own at a later date. And we're going to click on Lab 2 to move on in the menu. So now we're going to load and explore some data. So what we actually have here in the background is a Oracle database and what we call an OCI object storage. So those things were created when you provisioned this live lab for you. So we're going to load data that's in our notebook to those to the object storage, and then we can use the data that's in the object storage to do all the great things that Ramu told us about earlier. So it tells us here that we have a couple prerequisites. So of course we had to complete Lab 1 to import the notebooks, and we have to open the pre-built notebook with the slide lab. So to do that, we're going to actually just click on this button here that says Lab 2. And we have 2 options. I can go ahead and click this button up here to run all of the paragraphs, which I mentioned earlier. It will run all of the paragraphs in sequence, or I can go through and run each paragraph individually. So you can do whatever you want in this case. I'm going to I've already actually, these paragraphs actually run automatically, so I'm not going to do anything because it shows what our results are anyway. So just for time, I'm not going to run through them again. And what this is going to show us here on the left-hand side is to go through task 1 and then task 2 and task 3. But those will follow in the notebook as well. So to make it easier on ourselves, I'm going to expand the notebook so we can see a little bit better. But I know in the background that I'm following what's going on in the live lab because of how it was set up. And I hope that makes sense. So we'll start with task 1. And what we're going to do first is import libraries. So of course, with OML, we need to use a bunch of libraries. And if you had done the reading in lab 1, these things would make sense. So we're going to import these libraries and then configure some settings that we're going to do for this live lab. So we're going to enable geo data frames, do some fancy stuff with the display, and that's basically it. So we've imported some libraries and we did configure some settings. We've already made it through task 1. Do people want to give a thumbs up if you were able to run task 1 properly, if you have any questions? All right, I'm seeing lots of thumbs up. That's great. All right, so into task 2. So now we're going to load data from object storage to ADB. So, Zoom is asking for a passcode. Let me shoot a quick message to Ramu in the background and let her know that. I don't have her passcode. All right, let me see if I can get you an answer quickly. Keep an eye on that while I'm talking. Okay, so as Ramu told us during the introduction, and no, Simon, if you're keeping up here, you don't need to go to a breakout room. You're good to go. We're working with data from the state of California. So we have zip codes from the US Census, some demographic information from per zip code, which we also got from the census, and then electric vehicle car registrations by zip code, and electric vehicle charging station locations from the Department of Energy. So we're getting data from the census, a place called calmatters.org in the Department of Energy, and we're going to be able to bring all that data together and marry it and get some information out of there. So the first thing we're going to do is load the zip codes, GeoJSON, into our autonomous database using this script here. And then we're just going to quickly rename the zip code column names to something a little bit more intuitive. And that's just going to help us write more easily readable scripts later on. So we're going to rename it CA for California zip codes. And then we're going to rename this column to zip code. Because if you see here, excuse me, we're not altering the table name. I misspoke. So we're going to, in the table CA zip codes, rename the column from this really weird name to zip code. And then I'm going to go ahead and delete a zip code for Catalina Island because it's an island and these algorithms involve relationships of zip codes that are near each other. And of course, this island doesn't have anything near each other. So just to show that we can delete zip codes, we're going to go ahead and do that. And then we're going to load the charging station GeoJSON file to ADB. So this par URL is just saying in object storage on Oracle Cloud Infrastructure, this file exists, and we're going to load it into our database. And next, you're going to load the electric vehicle demographics data. So this data is not a spatial CSV file. So we're going to use this to access the data and write to a table because that doesn't exist in any other format. And then we're going to go ahead and load the electric vehicle demographic CSV to autonomous database. And that's going to return some information so we can see here that we're actually getting that data back. So for all of these zip codes, you can see how many electric vehicles by percentage are in each zip code. And then you can actually see the median household income and whether or not people in the zip code have a bachelor's degree or higher in the median home value. So you can see that some of these don't have any electric vehicles in the zip code, and some of them have about 14% of the households have an electric vehicle. You can see that what their household incomes are in comparison. And we'll go into that a little bit further later. And next, we're going to create what's called a spatial data frame and an OML data frame that are proxies for the database tables that we loaded. So we're going into task 3 now. So if you remember our workshop, we're still in lab 2, and now we're going into task 3. So we're going to create those proxy data frames that reference tables in our data center. And we're going to create proxy data frames here, referencing those tables using this Python script here. And it's going to print out the columns and the shape of what that's going to look like. And then we'll explore the demographics using Python to show us just the table of what that looks like. So this is the same information that we saw before, but it's just a little bit easier to read in this format. And we'll also show the zip code data. So if we see here, I have a zip code and then geometry. So that's the shape of the polygon of the zip code. So what the zip code actually looks like on a map. And then I can actually plot that. So I can see what those zip codes look like here. So if we look in here, I can see all like the little lines to show us what each one of these zip codes look like. And I'm just gonna hold on a second so people can catch up. So I saw that somebody asked what a proxy data frame is. So as Rahul said in the messages, just so everybody's on the same page, a proxy data frame allows you to load data into a data frame from the tables in the database. And by using these, we can easily materialize any changes to the table. Okay, so hopefully that makes sense to everybody. And I brushed over some things just to get us to the live lab because I'm worried about time. So if you go through the live lab again on your own, and Mellie's explaining that we can do that later, you can read each one of these paragraphs, and hopefully this will make a little bit more sense. Okay, so then we're going to identify all the zip codes within 10 kilometers of a coordinate location. So I have this coordinate location here, and I want to identify all the zip codes within 10 kilometers of there. And now I'm going to find all of the charging stations data. So we're going to explore that data now, and I can see that each one of these has an ID, and I can see what the facility type is. So is it a parking lot, a shopping center, a school, There's one at a brewery or distillery, and where it is, where the point is on the map. And we can plot those stations here. So we can see these are all of the different electric vehicle charging stations in California. So there's quite a few of them to choose from. And because we're using a data frame, we can plot that on the map. So then we're going to use within distance as a method to identify the charging stations within the distance of a zip code. So if you remember before, we looked at everything, all the charts. So what we're doing, sorry, is looking at a zip code, and we're going to identify all the charging stations within that zip code. So this is our zip code here, and I'm looking at 10 kilometers around that zip code. And we're going to see that here. And we'll use that information in lab 3. And Rahul is going to walk us through that lab. So I'm going to stop sharing my screen and send you over to Rahul.
Pause here, I think, for it, because we still have a good amount of time left. We have an hour left, so we can pause and see where people are. And people who don't want to wait can keep continuing in the lab. Yes, if you don't need more time, you can just give us a thumbs up or a thumbs down if you want us to pause and you need more time. Okay, so quite a few people are ready to sound their thumbs down. Some. Yes, Hector, that does often make sense that you can just watch Rahul and then you can do this on your own. The lab is available afterwards. You won't just be using the same event code. You can go directly to the lab. I pasted a link and I'll paste it again. The same thing, you would provision an instance, you log in using your Oracle account, provision an instance, and pretty much do the same thing. The event code basically helps us provision the resources because there are we started off with over 80 people, so we wanted to make sure we have instance, and that's where the event code is. This one. Okay, so Rahul, I guess you can maybe continue. Wow. We can always, at the end, we can help people catch up as well.
Sounds good. Hopefully, yep, okay, everyone can see my screen. So now we're going to step into lab 3. This is where we're really going to get into some of the nitty-gritty of spatial, and then in lab 4, we'll start running some spatial machine learning algorithms. So like lab 2, the first thing we're going to want to do is import some libraries. If you want, you can run each paragraph, paragraph by paragraph, or you can just click the run all button here at the top. It'll run through every paragraph, and you can just look through what's going on. So from here, once we import all of our libraries, we can just configure some settings about the display size, things like that. And then we can start to prepare our data. So the first thing that we might want to do is we have 2 tables that or a few tables are zip code with electric vehicle demographics, California zip codes, and public charging stations. So one of the things we might want to do after we create these proxy data frames, which loads data from the underlying tables into this notebook environment, we can then join some of those tables together. So in Python, we can do that just by using a merge data frame call here. But this is basically like doing a join in SQL if you're more familiar with SQL. And so when we do this, we are joining our electric vehicles and our zip code or California zip code information based on the zip code columns. So when we do that, we get our consolidated data frame. and then we could use that to work with it. So once we have that, we can first plot a map of our zip codes colored by the electric vehicle percentage. So the percentage of the population that has electric vehicles. We do that, we can see that we have a couple hotspots in a couple different areas. These are some of the major cities in California, which makes sense. And then the next thing we might want to do is analyze any missing data in our data sets. So when we run machine learning algorithms, we want to avoid any null values or any missing data. And so when we analyze, each of these data frames and we look at what rows have potential missing data, we can see that we're missing some median household income data and some median home value data. And so we can review those rows directly from our data frame. You can see that we have some null values, in these two columns. And so the next thing we might want to do is impute that data. So first, we can plot a map of what that looks like, and we can just kind of see where we're missing data. We're missing it in a couple key areas, like over here and over here, where we have some of those hotspots, as well as some of the surrounding areas. So we can do something called a spatial imputation. What that means is basically we can aggregate the data that is surrounding those areas and fill in our missing columns based on the trends that we see in the surrounding areas. The first thing we're going to want to do is do a Moran's I statistic test, which will just say, are we justified in, addressing if there's some kind of
screen. I'm sorry, we lost your screen.
Okay. I've run into this with Google Meets a couple times where my screen just stopped sharing. So thanks for pointing that out, Melly, and I'll try to keep an eye on it. But yeah, like I was saying, the first thing we're going to want to do is run a Moran's I statistic test, which basically assesses, are we justified in imputing the data based off of the surrounding areas? So when we run this test, we're going to come back with two values. One is the Moran's I value, which it basically, if it's positive, that tells us that there is a correlation between the surrounding areas and any of the areas that we're looking at for that value. So in this case, that's median household home value and household income. And then we have the p-value, which just means, is this statistically significant? So if it's less than 0.005, that generally means that it's statistically significant. So from the results of this test, we're justified in using the spatial imputer. So when we call this, it's called the spatial imputer. And what it does is it assesses the nearest neighbors of our of each of our values that have nulls, and fills it in with a basically an aggregate of any of those missing columns. And so when we do that, we can replace the columns with the imputation results, and then we can see here at the end that we have no rows with any missing value in any column. And so now we have a complete data set, and what we might want to do next is engineer a new feature. Again, this is all just part of preparing data to run some analysis. So one thing that might be useful is figuring out how many charging stations are there within 10 kilometers of each zip code. So when we do that, we're really running a within distance function in the database, but by using these proxy data frames, we can run the same SQL statements that we'd run in the database just through a really simple Python API call. So here, we're basically just running a within distance function in the database. If you're familiar with Oracle Spatial, if you're not, don't worry about it. Basically, this is just saying, are there electric vehicle charging stations within 10 kilometers of each given zip code? And so we can do that, and then we can push those results into our data frame. And now we can append those zip codes to with no charging stations within 10 kilometers as well. So we still want to fill in any of those null values. So we can do that just by replacing any of those nulls with a 0. Okay, once we do that, we can save this prepared data into our database. This is again, like just part of using that spatial data frame. And from there, we can save our our other data frame into the database as well. So now we have our zip codes with prepared electric vehicle data, and we have our home values and geographical demographic data saved as well. And so from here, we've now prepared our data using the spatial imputer. We've also engineered a new feature using the within distance function. And now we can head over to lab 4 to start running some analysis. And so before I do that, I'll pause and see if there's any questions. If you have any questions for now, just put it in chat. I see a question from Gil. Is OML a parallel for Pandas? Not exactly. You can actually use Pandas within OML. OML is a platform that includes a number of packages, including these spatial AI packages. The spatial imputer, what's it doing? So if I scroll back up here, we can take a closer look. The spatial imputer is basically looking at, it assesses based on a weight. So here we have the weight being the 5 closest neighbors of a given zip code. And then it basically runs an algorithm to fit based on the aggregate of those neighbors for the median household income and median home values. So it's basically saying, based on these 5 nearest neighbors, what is likely to be the home value for this area. And again, we don't want to do this all the time. We only want to do this when we get a positive Moran's I test with a p-value of less than 0.005, because that just means that it's statistically significant and we're seeing a positive correlation. I think, yeah, screen share stopped again, but I think that's all the questions that I see. So I'll jump back into lab 4. So we can go back to our notebooks and head into lab 4. Okay. So once we're in our lab 4 notebook, we're going to create, the purpose of this lab is to create some predictive models. So very similar to some of the previous labs, the first thing we're going to want to do is prepare some import some of our libraries and configure some settings. And when we do that, after we do that, we can create training and test data. So we have, these few tables. And so the first thing that we'll do is, again, load those tables into a spatial data frame. And once we've done that, we can split that data into training and test sets. So we're going to split in a ratio of 8:2. And we'll have our training data, both for our zip code electric vehicle percentages, as well as that demographic information that we have. When we do that, we can see a histogram of our training data of the number of observations and the percentage of electric vehicles. And we can see this data is kind of skewed in one direction. When we run these analyses, we're going to want a more normalized data set. So what we can do is a log transformation. So we can apply a log transformation on, we can apply a log transformation on our data set and just add a small value here so that we don't have any log zeros when we're running this transformation. And then we can see what our transformed data looks like. When we do that, we can see it's a more normalized data set, right? That's kind of represented through a bell curve. So once we have this bell curve, we can start to run some analyses. So the first thing that might be relevant to look at is what does our data now look like after we've run this transformation? And what we can see is that we see these, basically this pulls out the hotspots. So we can kind of see by transforming this data, instead of everything being really, really low percentages, we can kind of see that there is still some variation in these more outlying areas. And so by transforming the data using that log transformation, we're able to kind of assess this a little bit better because we have a more normalized representation of what these trends actually look like. So now that we kind of understand that, we can actually start to run some predictive models. So we're going to run a few predictive models. The first is a spatial adaptive regressor. This basically picks between 2 regression models. One is the spatial error regression, and the other is the spatial lag regression. So the adaptive regressor basically looks at the statistics in our data set and decides what algorithm or what model would be better to run for our use case. We're also going to run a geographic regressor, which is a more targeted model that will look at each individual geographic location and assess basically a mini model for each zip code. And then the last is an OLS regressor, which is a non-spatial OLS regression. And this is just kind of useful to assess the spatial effects and determine the most suitable spatial algorithm. So when we do that, the first thing we'll do is assess or assign a spatial weight. This is, the k nearest neighbors weight definition. So what this is saying is that we're going to assess our weight based on the 5 nearest neighbors in any given zip code. And then we will create some statistics. So we'll create a data frame, which we will use to store all of our statistics from these machine learning algorithms. So that's our AIC, PI, which is the Moran's I test that we ran earlier, the p-value, as well as the mean squared, the mean squared error. And for most of these, the AIC isn't particularly relevant all the time, but for the Moran's I test and the mean squared error test, we generally want to see lower numbers. The lower generally means the better. Okay. And so first we'll create this data frame with our headers, and then we can go ahead and start creating these models. So first we'll create a model using the spatial adaptive regressor. And we'll use, if you're familiar with machine learning, you might be familiar with scikit-learn, which is a package that allows you to do a number. And I'm seeing I lost my share again. But scikit-learn basically just has some, the ability to run some machine learning, to build a more robust machine learning pipeline. And so what we're going to do here is in our spatial pipeline, we're going to scale using scikit-learn's robust scaler. So then we can apply these machine learning algorithms with a higher degree of scalability, right? Then we'll train our model on our training data set. And then we will see what algorithm was chosen by our machine learning or by our spatial adaptive regressor, and it chooses the spatial error regressor in this case. And then we can actually run that pipeline, right? And we can see a number of our a summary of our output for this model, and we can see, for example, the number of observations, the mean dependent variables, as well as some other statistics in here, right? I'm not going to get too deep into this, but basically we can now compile those statistics and add them to our data frame, right? And so when we do that, we can see, we have our AIC, our Moran's I test, p-values, mean squared error training or mean squared error test, and so on. And so now let's create the same, we're going to do the same thing, but instead of using the spatial adaptive regressor, we'll use the OLS regression. So this is using not a spatial specific machine learning algorithm. This is a standard OLS regressor. And so when we train the model, again, using the same steps as before, we'll train the model, and then we'll output the summary of our results. And then once we have those, we can then, again, we can see our Moran's I value, et cetera, and then we can add those to our statistics. So when we do that, we can kind of start to compare these different models, right? And that's kind of the whole point of why we're running 3 different models in this case. So we can see which model is actually going to be best for our given use case. And so now we can apply the geographic regressor algorithm. This creates a global regression model and local regression models for every training sample. So for each group of zip codes, it's going to create local regression models so that we can get very specific tailored insights into what we can predict based on different geographic locations. And so to run this, again, it's very similar. We just have a few more things that we need to kind of add to our call for the geographic regression algorithm. So, we're going to use a linear regression. We're going to use a local weight of 0.1. And then we're going to use our spatial weight that we defined earlier, which is our 5 nearest neighbors. And so when we do that, we can train the model and then compile our statistics once again. And once we compile our statistics, we can add it to our data set or to our data frame. And now we can really start to compare these 3 models. And so we can see the difference here in the Moran I value. We can see the difference in the mean squared value, et cetera. And really what I want to point out here is that in some cases, we have lower values from the spatial adaptive regressor, such as the Moran's I on training and Moran's I on the test data set. But in some cases, we have also very low values from the geographic regressor, such as the means error on the test data set and on the training data set. So what we're going to do next is we're going to do an ad hoc prediction based on some different variables. And we're going to use the spatial adaptive regressor and the geographic regressor and see what the differences are. And so this is task 4. And basically what we're going to do here is we're going to say, we're going to define some independent variables. So that's the percentage of bachelor's degree or higher, the percentage, the median household income, the median home value, and the number of charging stations within a 10 kilometer radius. And we'll do that on a few different locations. So we basically just create a geometry. So this is representative of 4 different points using latitude, longitude coordinates on a map. And then we can run the geographical regressor and the spatial adaptive regressor on these on this data set. And so when we do that, we get these values, right? And basically what this is saying is the spatial adaptive regressor is going to provide a global prediction of this for this ad hoc data set. So in this case, this is saying and I lost my screen share. Okay. So this is basically saying this is the percentage of electric vehicles we expect to have at these locations globally, whereas the geographic regressor is going to say this is the percentage of electric vehicles that we expect to have at each point, right? And we can kind of notice here that per point we see a different value, right? So at this last point here, we see almost 2 times the number that we would expect from the first point, and the adaptive regressor falls kind of somewhere in the middle. So based off of these values, depending on what our use case is and what we're trying to assess, we might want to choose the geographic regressor over the spatial adaptive regressor or vice versa. And one thing to note as well is just that you can just really easily run these kinds of algorithms, assuming that you have some spatial data, and apply any of them depending on what fits your use case best. And so that brings us to the end of this lab. If there are any questions, we can take them now. Otherwise, I'll stop sharing and hand it back over to Ramu.
While we're waiting for Ramu to join, I just wanted to highlight again that the lab will be available. The event code ensures you get an instance because we have a lot of people together. So we have some pre-provisioned instances, but you can provision your own instance. It'll work exactly the same way with your Oracle account. I think Ramu is also going to step through how the Oracle free tier that gives you access to a free instance of Oracle database in the cloud. So you can run it and then keep your instance, because anything you run with the live labs temporary provisioning of database goes away after a few hours. If you use the free instance, it'll be there. Now you're on mute.
Ramu, you're still on mute.
Ramu, we still can't hear you.
Hey, Ramu, you are muted. We cannot hear you.
Can one of the admins unmute her? Is that possible?
We can send a request, but she had to mute by herself.
Ramu, I don't think we can hear you. I'm sorry.
Oh, I bet she has.
Oh, I think she
I
has
bet
the
she has
audio.
it on no sound because she was in the other in Zoom.
Okay, so how are we going to
So Denise, do you have the slide, or someone else can walk through this, or you or someone else can walk through this, I guess, if you have the slides.
Yeah, so on the screen, Ramu is showing us that you can actually sign up for an Oracle Cloud credit, and you'll get $300 worth of cloud credits here. So if you click on this QR code or the bit.ly link, I guess we lost that. Sorry, guys.
It's an echo. Hold on.
Oh, Ramu's off mute now.
We still can't hear her.
I'm getting feedback. Is everybody else getting feedback?
Yeah, I think it's because Ramu also has the Zoom open.
This is bad.
So I muted Ramu, now we can try Denise again.
Okay, so some takeaways from today. So you can use Spatial AI algorithms and APIs in the OML notebook. I hope that was really helpful for you today. And you can do some pre and post processing in your OML notebook, so you can get more data out of those notebooks, and then you can use the Python API for common spatial operations. Okay, so again, here's that QR code, and if you go down below, there's a bit.ly link if the QR code is not helpful for you if you're on your laptop. So using that Oracle Cloud account, you get 2 autonomous databases with 20 gigabytes each, 4 instances of ARM compute, 20 gigs of block volume, and 10 gigs of object storage. And that's available to everybody on this call. And if you have that Oracle Cloud account, you can get into those live labs. So if you go back to where we started, the livelabs.oracle.com. There's actually a plethora of other live labs in there that you can click it. You can go through and look at.
So if people are asked, can we get access to 23 AI database? This is the way to get access to it kind of on a permanent basis. Like after you finish your $300 cloud credit, you will still have access to the database. The credit just helps you do a few things, but the basic free service will still be available.
Right. So to sign up for an Oracle Cloud account, I think what she's talking about now is you click on this bit.ly link, which will bring you to this web page, Oracle free tier, and you click on whatever step 2 was. Sorry about that. You'll verify your email address and put in very similar information that we saw when we were creating our Live Labs account. And one thing to note is to do this, unfortunately, you will need a credit card. So I'm sorry. I know that's a bridge too far for some people, but you do need to have.
It will not be charged. It will not be charged unless you even after the credits are expire. It won't be charged unless you explicitly say I need to charge it.
Correct. Yep. So you do need to have one on file, but as Millie said, you won't be charged for anything unless you do anything that requires payment, and you will get a warning on that. And then just a plug for Oracle AI World, which is happening in Las Vegas, October 13th through 16th. So if you'd like to join us in Las Vegas, we'd love to see you. Ramu, Rahul, Melly, and I will all be there. You can come to our events, and you can register there. So it looks like Ramu and I ended at the same time. And if you want to stay on and ask any questions, we'd love to see you there.
And we'll still be here till 2 o'clock. There's 25 minutes more. So please continue working on the lab. You have the instance. We'll be here and happy to answer any questions.
I think Ramu just realized that we couldn't hear her.
Yes, I'm sorry. I just did a whole presentation by myself.
Well, Denise talked. It was great. You were very much in sync. It worked out well.
Oh, thank you so much, Denise. So because of the breakout room, I had to mute everyone, and I just realized my mic was not in the right place. But thank you, Denise.
Ramu, since we have some time, do you want to go back? And I glossed over what you were talking about when you were doing the slide about all the great things about spatial AI and OML. And I think I definitely missed some really key points. So if you want to do that slide again, I think with the time that we have remaining, that would be valuable.
Okay, yes. So
Yeah, this slide.
some quick takeaways. Basically, right now, we can use Python APIs to perform spatial ML algorithms. We can also do spatial pre and post processing, meaning that we can enrich our data sets using spatial or location data, as well as filling the gaps, which will help us make better predictions, more accurate predictions, and more accurate detection of patterns. And then we're also using Python APIs for common spatial operations. So meaning that even though right now in the database we do it through SQL, we understand that Python is a very popular language that developers and data scientists are using. So it's way easier and more accessible for everyone to use our spatial operations. So yeah, I hope you guys are able to apply this in your day-to-day, because as we said before, everything happens somewhere, right? So most people have location in their database or in their data sets, and it's an awesome way to leverage and basically get better predictions and better detections when it comes to our creating our models and getting better results. So yeah, and I hope it was useful and you guys learned a lot in this session. So yeah, do you guys need anything else? Maybe the QR code, just for you guys to be able to scan it and create that account?
I think you can just leave the page on.
Okay.
Well, several folks commented they like the lab. I'm glad. Yes, indeed. We have a powerful tech stack. People just think of Oracle database as a relational database, but that was so long ago. Now Oracle has the database has all kinds of cool stuff, all kinds of cool things you can do.
Great, thank you so much. We have a few minutes. If anybody want to have any questions or feedbacks, please feel free to share in the chat. And also, I know we have quite a few follow-up resources links. I will put all of those links to the follow-up emails. We'll send it shortly after the session is done. And also, this session is recorded. You can come back to watch the recordings, follow the steps, and as the speaker said, those code labs still there, and you can try out, redo it. I know, at the beginnings we have some struggles with set up the environment, log on the account, but you can try it again, a few times. And go through those steps. If you haven't finished that one yet, don't worry about it. You can continue to do that I think each labs they have like a bounded like a couple of hours, but you can do it once the timeout, you can try it again. And also we have like a survey for the code labs. I will send the link to the chat. Please to do one is scan the QR code. It's a very short surveys, tell us about the code labs, the workshops, all the events. And also we have another one to track the progress for this code lab. Let us know, if you complete or if you start or where you start, and any feedbacks. I really appreciate all of the feedbacks give. And also we're going to run a lucky draw for those who submitted the feedbacks, report the progress, and we will have some swags, some backpacks, some hoodies, t-shirt, for those who submitted the topics, submitted the progress report. Let me send the link to the chat. And also we have the Discord channel. If you have questions later on, feel free to post in the chat. We will answer it in the chat offline.